Hey, how's it going? This video is going to cover chapter 2.5 in the geometry textbook. We're beginning to write some proofs now about some geometric diagrams. In this case, we've got two lines that intersect each other and a bunch of smaller segments that are created along those lines. Right. So to kind of introduce proofs, you can see that the proof has already been done, and then just certain pieces are missing. So this is kind of a fill in the blank type of proof. So we're not doing it entirely from scratch, but we're just trying to fill in the pieces. All right, so let's see what we know. Line K and line L bisect each other. So I'm going to highlight that word because we're going to have to come back to it later, right? And we need to know what the word bisect means at point M. And then we also know that segment BM, which is kind of in the lower right, is congruent to segment CM, which is in the lower left. Okay. Now, because I know that, I'm going to go ahead and mark them in the diagram. Remember, we use a little red tick mark, right, to show that two segments are congruent. Okay, so segment BM is congruent to segment CM. Okay. Now, what we want to prove is the segment AB, which is this long segment here, is the sum of segment AM and DM. So this length plus that length is the same as that total length there. Right, so what you'll see here is that the first statement in our proof is one that we were given, right? Segment BM is congruent to segment CM, and the reason is just that it's given, okay? So there's really no thought involved in writing the first line in our proof. All right, next we have that segment CM is congruent to segment DM. Okay, so CM is the segment here on the lower left, DM is the segment here on the upper right. Okay. Now, let's go back to this word bisect. Okay, when something is bisected, right, it is cut in half. It is cut into two equal halves. Okay, so the segment CD has been bisected, which means it has been cut into two equal halves. So the length of this half over here is the same length as this half over here. Okay. And so we're just relying on the definition of the word bisect. Okay, bisect basically means to cut into two equal halves. So we're going to write definition of bisect. Okay, to cut in half. Right. The third statement says segment BM is congruent to segment DM. Okay. So BM, which has a single red tick mark, and DM, which also has a single red tick mark, because they were both congruent to CM. Right. You see here, BM is congruent to CM, and then we know that CM is congruent to DM. Right, so that's kind of a chain of events, right? This thing is congruent to a second thing, which is congruent to a third thing, and we could continue that chain of events, but we stop after three things, right? So ultimately, we want to say the very first thing is congruent to the very last thing, or the third thing, because they're both congruent to that second thing. Okay, this is the transitive property. Okay, and here we're applying the transitive property to segments. Okay, so the official name is the transitive property of congruent segments. Okay. Right, next we have that the distance from B to M is equal to the distance from D to M. Well, this is true because the segments are congruent, and we know that congruence means the same length. Okay. So we're just relying on the definition of the word congruence, right? If segments are congruent, then the segments have the same length. They are equal in length. If it were angles that were congruent, then angles would have the same measure. They would be equal in measure. All right. Now the next statement is missing, but we do kind of have a clue of the reason for it. So it says segment addition postulate. Okay. So segment addition postulate says that two smaller segments that are next to each other add up to the longer segment. Okay. Well, that applies in two places here, right? Segment CM and MD are next to each other, right? So I can add those together to get the longer segment. Or AM and MB, those two segments are next to each other, and so I could add them to get the total distance A to B. Okay. So which segments do I want to add here? Well, to guide us, let's look at what we're trying to prove. Okay, we're trying to prove something about AB. All right, so that's right here. Let's highlight it. Okay. So AB is a long segment, which is made up of two smaller segments. So let's do segment addition with those two pieces there. Okay. So we can say that AB is equal to AM plus BM. The two smaller segments we know add up to the larger segment. And then we get our last statement, AB is equal to AM plus DM. So that looks almost like the last line, except the BM term has been replaced with the DM term. And this happened because we knew from step 4 that they were equal to each other. Okay. So what we're performing here is a substitution, right? Since BM is equal to DM, we can substitute them, we can swap them in and out anywhere we'd like. Okay. So we could swap the BM here with DM instead. So we're just making a substitution. Substitution property. Okay. And there you have it. That's our first kind of geometric proof that we've done in this class. Okay. All right, so stay tuned, because in the next video I'm going to do another proof. And again, just kind of going through this blueprint of two columns, right? Statements on the left and the reasoning on the right.